guys, it's me again. So today we're going to be taking this integral, and there are a few different steps to it, with a few different things that you've learned. So the first thing that we look at is if we can do this simply, and no, we can't. So our next step is there any way to simplify it so that we can handle it by maybe integration by parts or something. So what I see is there's an x squared and there's an x. So we can probably simplify it by doing a u sub. But since in a little bit we're going to be using some other variables like u and v, I'm going to be using y for my u sub. So y equals x squared and dy equals 2x dx. But when we're plugging all this back into here, we notice that there's no 2. So I must divide it 2 and divide it 2. So that it's dy over 2 equals x dx. So now we look in here and we see what matches our u sub. So we see that our x squared equals y, which is in the natural log, right? So we have natural log of y. And then we see that there's an x and a dx. So we look for the x and we look for the dx, and we notice that they're both there. So we know that we can substitute our dy over 2 in for those two values. So we have dy, and we can put the 1/2 on the outside to make it easier for us because it is a constant. So when we look at this, do we see a simple way to do anything? No. So we must do integration by parts. And this one's a little tricky because there's not just like two values that we can do. So we do u, du, and dv, v. We have to kind of think outside of the box for this. So if we were to put natural log of y right here, do we know how to integrate that to get v? No. That's why we're doing this. So we must do natural log of y right here. And then for du, we have dy over y. So, and then our dv, we can actually just do as dy, because it is something in the integral, right? Which, when you integrate, you just get y. So now, we're going to go to our next step. We'll do it right here. So our 1/2 can just go on the outside. Remember, it's uv minus integral of v du. So we have uv, which is y, natural log of y. And then we have minus the integral of v du. So we have dy over y times y. Now we can see how this simplifies to just dy, right? And as we said before, when you take the integral of dy, you just get y. So we get 1/2 y, natural log of y, minus the integral of dy, which is just y. Now, if we were to just leave it here, this wouldn't be correct, right? Because we did the u sub, or y sub in a way, above. So we got to insert all that into 1/2 x squared natural log of x squared minus x squared. Now, a little interesting trick here is that whenever you're taking like the natural log of y or something, it's usually going to end up in some sort of format like whatever's on the inside times natural log of y times natural log of whatever on the inside minus whatever on the inside. This is usually a pretty good formula to look back at, so like if your answer wasn't to match this kind of formula, you know there'd be something kind of wrong. So yeah, adios amigos.